Hello students, in this video we will study one more mean value theorem, that is Cauchy's mean value theorem. Now let's see what is the statement of this theorem. If fx and gx are continuous in closed interval a to b and differentiable in open interval a to b. Both these functions are continuous in closed interval a to b and differentiable in open interval a to b, then there exists at least one C belongs to A to B for which f of b minus f of a upon g of b minus g of a, this is equal to f dash c upon g dash c. This is statement of Cauchy's mean value theorem. Now from this expression, generally students think this is ratio of LMVT or mean value theorem for functions fx and gx. What they do, they divide numerator and denominator by b minus a. So we have f of b minus f of a upon b minus a. This upon g of b minus g of a upon b minus a. This is equal to f dash c upon g dash c. Now the argument students put is that this is a mean value theorem statement for function fx, and this is mean value theorem statement for function gx. So we are actually dividing these two statements, but this is not true always. Let's see on the graph. We consider interval a to b. In this interval, we draw the graphs of fx and gx. So we have, this is the graph of fx, and suppose this is graph of gx. This is y is equal to fx and this is y is equal to gx. This is point a comma 0 and this is point b comma 0. We have interval a to b. The coordinates of this point are a comma f of a. Coordinates of this point are b comma f of b. For this point coordinates are b comma g of b, and for this point coordinates are a comma g of a. Okay. Now for mean value theorem, what we do? We join these 2 points here and we join these 2 points on the graph of function y is equal to gx. Now on the graph of y is equal to gx, we consider a point where tangent is parallel to AB. So we have this point on the graph of y is equal to fx. At this point, this tangent line is parallel to chord AB. This is point c comma 0, and on the graph of function y is equal to fx, this point is c comma f of c. The slope of tangent at this point is f dash c. So we have f of b minus f of a upon b minus a is equal to f dash c. Now for this point, the coordinates are c comma g of c. Now if I draw tangent line at this point, then this may not be parallel to this chord, which is visible from the graph. That means g dash c is actually not equal to g of b minus g of a upon b minus a. It may happen sometimes, but mostly or in general this is not true. The value of c for which f dash c is equal to this may not give this is equal to this. That means this is not actually ratio of mean value theorem for two functions. Then how can we prove this statement? Let's see the proof. We prove this statement using Rolle's theorem. Now for Rolle's theorem, what should be the function? For that, what I do, I cross multiply and take all the terms on one side. So I get g dash c multiply by f of b minus f of a upon g of b minus g of a minus f dash c equal to 0. That means now we have to prove that there exists at least one c belongs to a to b for which this is equal to 0. And now this is derivative of function gx multiplied by f of b minus f of a upon g of b minus g of a minus f of x. So we consider this function, suppose this is function hx. Now on this function we will be using Rolle's theorem, but for that it must satisfy the conditions of Rolle's theorem. It is given that fx and gx are continuous and differentiable, so this function is also continuous and differentiable. Moreover, the values of h of a and h of b must be equal. The value of h of a, this is equal to, put here x is equal to a, so we have g of a multiplied by f of b minus f of a multiplied by g of a. Then we have f of a multiplied by g of b plus g of a multiplied by f of a, this upon g of b minus g of a. Now here f of a, g of a, this term gets cancelled out. So we get h of a is equal to this. Now if I put here x is equal to b, then I get h of b is equal to this expression. You can verify by doing on your own. You will get h of b is equal to this. That means h of a and h of b are equal. Now we can use Rolle's theorem. Now what is statement of Rolle's theorem? There exists at least one c belongs to a to b for which h dash c is equal to 0. The derivative of this function at x is equal to c is this. So this is equal to 0, and from this we get this ratio is equal to f dash c upon g dash c. तो यहाँ पे जो प्रूफ है वो रोलेस थ्योरम से है, पर उसके लिए हमें क्या करना था, एक प्रॉपर फंक्शन चूज करना था जिसके लिए हम ये थ्योरम यूज करेंगे. Now let's try some questions based on this theorem.